During a solar eclipse, when the moon obscures the sun, you can see the distant stars, and according to these ideas of general relativity, the distant starlight should travel on a curved trajectory on its way to the Earth, being moved, deflected by the sun, and that would therefore shift the star's apparent position in the sky. So if during a solar eclipse you could take photographs of the background stars and compare their positions to where they appeared 6 months earlier, when the sun was on the other side of the Earth and having no influence on the trajectory of the starlight, a tiny shift would be apparent if Einstein's ideas are correct. It's a little tiny angular difference, but Einstein could calculate what it would be.
The usual form of gravity that you and I know about is the attractive version. You drop something toward the Earth and it moves downward because the Earth and the object pull on each other. That's the ordinary gravity that we experience every day of our lives. Einstein's equations actually allow gravity to also be repulsive. It can push outward as opposed to just pulling inward. Gravity created by a rocky object like the Earth is always the attractive variety. The gravity created by the sun is always the attractive variety. But Einstein's math shows that if you don't have a rocky object that's isolated in space, but rather energy that is uniformly spread through a region of space, that kind of entity yields repulsive gravity.
The previous problems were that Einstein's ideas of how gravity works, his general theory of relativity, and the other theory of the 20th century known as quantum physics were at loggerheads. They each said the other was wrong, even though each worked in its own domain. String theory finally describes a universe in which those two ideas are put together, stitched together into one framework, and we think it makes sense.
Einstein's equations have now been tested over and over again in a whole variety of circumstances. The detection of gravitational waves just a couple of years ago is like the crowning triumph of Einstein's math. 100 years ago, the math says there should be ripples in the fabric of space. 100 years later, we finally detect ripples in the fabric of space. So we are very comfortable with any prediction that comes out of Einstein's mathematics.